Cosign in the client libraries is not the name of a jam band of Colleen, Cody, and Zach, or maybe I should say it's not yet the name of a jam band. Instead, this is sort of a Cosign State of the Union talk. What we've seen, Cosign, of course, is the very popular CLI that lots of people are using with Sigstore. However, as there's been adoption of Sigstore across all of these programming language ecosystems, what we found out is that people want to use a client library for Sigstore that's in the programming language of their ecosystem. That's the client libraries. They've had lots of great new features added to the client libraries, but those features haven't always made their way back into Cosign. So we're going to talk about the work that the three of us have been doing to bring it up to date and what's next for Cosign. So this is a trick that I stole from William Woodruff, starting out with some sort of timeline and talking about the history of things. It's worth remembering that Cosign is old, maybe not old like the hills, but old relative to the age of Sigstore as a project. It was one of the very first components to be released in early 2021, and the earliest client library release I could find was Sigstore Python. That was almost a year later. So before that point in time, Sigstore behavior was defined by whatever Cosign did. But then when we had the client libraries, it was great because this is helping us increase adoption, but now there's two. And so we need a way of keeping the different client implementations in sync, compatible, and supporting similar feature sets. This work began with the conformance testing suite that was released in late 2022. So here we're starting to codify the verification API, use case, test cases for successful verification and verification that should fail. And then a little bit after that came the protocol buffer specification. We're going to be talking a lot in this talk about the protobuf spec repository, in particular the bundle file format and the trusted root file format. This is to ensure that all of the client libraries are using interoperable files so they can understand and communicate with each other. And then I was shocked when I was starting to put together this timeline that the first public release of Sigstore Go that I co-maintain was in early 2024, this calendar year. People have been very generous with their feedback about Sigstore Go. They say, oh, it's such a clean code base. The API is so nice to use. Well, that's probably true, but we also stood on the shoulder of giants. There's so many things that we learned over years of Cosign development from previous client libraries, and we were able to start once the conformance testing and the protobuf specification was much more mature and use those lessons to produce a cleaner implementation. Sigstore Go and Cosign are kind of useful to compare to each other. They're both written in the Go programming language. Sigstore Go doesn't provide a CLI though, it's just a library, where of course Cosign is the CLI that we're expecting many people to use in the Sigstore ecosystem. So here's the dream of what we're headed for. There are all these language ecosystems that we've heard about today that are adopting Sigstore, including NPM, Homebrew, PyPI, and then there's work underway for Ruby Gems and Maven Central. And so we want Cosign to be able to understand and verify the content produced in all these ecosystems, where before we undertook this work, it couldn't. It's also really important that as we operate the public good instance, we want to be able to easily rotate the key material that public good instance uses, both as a general purpose security good practice, but also in case of security incidents. And today, that's not the case. There's verification copaths in Cosign where you need to update the version of Cosign you were using in order to make use of newly available verification material for the PGI. And then these last two are very related. There's verification paths in Cosign that require network access to query recore during the verification. This is bad for a number of reasons. We don't want the availability of verification to depend on the uptime of recore. And then also lots of people want to use Cosign in networks where there's limited or maybe even no connectivity to the general internet, so-called air gaps deploys. And so one of the features that we want to support across Sigstore is the ability to do offline verification. And then related, there's a bunch of verification paths in Cosign where it's using recore as an attestation store. So this doesn't scale very well. We don't want to be in the business of storing user data. And again, we want verification to happen without having to query recore live in the middle of the verification path. Okay, this might be remedial for this audience, but very briefly, what is verification? There's a couple of different inputs that we need to think about. First and foremost, our signed material. So maybe we have a OCI image or a file on disk with the signatures and the other metadata attached. Could be Fulcio certificates, could be recore entries, could be timestamp authorities. Then we have the verification material. So what Fulcios do we trust? What timestamp authorities do we trust? Often there will be a difference here if you're using the public good instance or if you're using a private deployment. Your private deployment is going to have its own verification material, and you need to supply that in some cases. And then there's also this concept of a policy. So if you're signing with a long-lived key, what long-lived keys are valid for what sort of contents? If you're using workload identity, which we saw earlier today, most recore entries use, that identity actually could be a workload identity or it could be a user identity, and then you need some sort of policy about what workloads or what users you trust to sign content. Policy is a really complicated topic, and fortunately in this talk we're not going to get into it in much depth. I think there'll be some talks later today about policy. And instead we're really going to focus on the shortcomings in the sign material and the verification material. So Cosign is such a Swiss Army knife in that there's so many different ways and configuration options that you can use, which is both like a blessing and a curse. Here we're showing the confusingly named Cosign bundle format, which is not to be confused with the new protobuf bundle format. So when you're signing something with Cosign, you might end up with just a bunch of files on disk. That's very inconvenient because then you have to figure out how to distribute and store all those different files. And so before there was the protobuf bundle, Cosign had its own concept of a bundle where it tried to put as much of that information as possible in one file. But the early iterations of this file have a lot of shortcomings. It has room for a recore entry, but it doesn't have room for an entry from a timestamp authority. And so depending on your use case, depending on if you're using the public good instance or a private deployment, you might end up with a separate timestamp file that you have to ship around with the bundle, which is very inconvenient. The recore bundle is incomplete. So it has the signed entry timestamp. You could use that to establish a concept of verification time, but it doesn't include the inclusion proof. So if you want that inclusion proof, you have to query recore during the verification. This is, again, sort of a security and availability concern. And at least if you use the Cosign bundle, it includes the attestation. You're not using recore as an attestation store. But in other use cases, you might be using recore as an attestation store. And so how do we fix all of these gaps in the Cosign bundle? I've already alluded to it a couple of times. So we learned from the experience of deploying and using those Cosign bundles to make the protobuf bundle specification that all of the client libraries support. You can see here that it not only includes room for recore entries, but also for entries from timestamp authorities, which is great. You have everything all in one file. It's very convenient. And the recore entries are comprehensive. So it also includes the inclusion proof. You don't need any additional content to query online in order to perform your verification. There's two problems on the verification side. And so the first, again, has to do with the file format. And again, Cosign is the Swiss Army knife. It's kind of hard to represent all the different ways that can be used. But here we have invocation where we're verifying the signature of a file on disk. And let's say we're not using the public good instance. We have our own private deployment, but it has the same sort of structure as the public good instance. Well, you have to provide a certificate chain for your private Fulcio. If you're using a private timestamp authority, you can also provide a certificate chain for that. If you're using a private recore, you give it the URL of that server, and then at verification time, it queries that server for the verification material. So this is not great. If an attacker is able to compromise your server, they can both serve out malicious content as well as tamper with the verification material that you're being served out. You really want the verification material to be distributed out of band of the verification to happen beforehand so someone can't so easily tamper with it. And like we've been saying before with the previous slides, you have all these different files on disk that you have to keep track of. It's very inconvenient to use Cosign in this way. Again, a pretty easy solution here from the protobuf spec repo. We have a trusted root.json file. Everything's contained in one file. It's very easy to distribute. It contains the Recore verification information that you need. So here that's the public key for the certificate transparency. And you'll notice that for each of these entries in the JSON, it's a list. It's not just individual elements. This is because it supports key rotation very easily. Every element in that list has a start time, it has an end time, and so if you need to provide new key material that's valid at a certain date, the format very easily accommodates that use case. This does introduce a wrinkle that's going to become important in a couple slides, and that is when you're verifying for some time ranges, there's actually two sets of verification material that are valid, and you need to handle that case. So put a pin in that. We're going to come back to that in a few slides here. But using the trusted root.json file itself isn't sufficient. So there's also the question of how you get that file to users. Again, we want to distribute our verification material before we performing individual verification. And the way that works today in Cosign, I guess I should say first that what I'm representing here is the tough repository for the public good instance. So this is a list of all of the tough targets, the files that you can fetch via tough. What Cosign does today is it fetches individual files for Fulcio, for Recore, and then uses that to perform the verification. And you can see in the file names what the problem is. We've already rotated the key material once, and we ran into this problem where, okay, we already used fulcio.cert.pem, it's expired, so now what we do, okay, let's append underscore v1. And then we'll update the client and say, yeah, okay, we know this was the file name, but use v1 now. That's what you should be using going forward. And you're kind of caught between a rock and a hard place where you either update this for all verification, and then you break verifying all signatures that happened before that point, or you kind of build in some concept of like, okay, starting at this time, now use this file name, but then everyone has to update their Cosign client to verify new material, right? We want key rotation to be seamless. We don't want people having to update their software in order to handle a key rotation. You won't be surprised at what the solution is here. Use the trusted root.json file. That is one of the tough targets. And like we said before, it's very convenient. It's a single file. It handles key rotation. It has all these really nice properties that we want that make verification much easier and lets us support some of these like longer range use cases. Okay, so those are all the problems and all the ways to solve them. If only it was so easy. So we can support the new flow, right? We can say, okay, great, stop using Cosign bundles, use protobuf bundles. Stop using disparate verification material, use the trusted root. But like we saw earlier today, there's millions, there's tens of millions of entries in Recore. There's people who've been using this for years. We can't just abandon them. And so we have kind of a three-pronged approach. We want to support the new use case so that for people who are newer to the ecosystem or people who are willing to make a breaking change, they can start using these new file formats. But then we have to figure out how to build interoperability. So let's say you moved using a trusted root, but you still have all the signed material. What does that verification path look like? And then also, how do we build migration tools so that people could either take material that they signed previously, or if they're running their own private instance, how can they create the trusted root file that we're asking them to verify with going forward? So I keep coming back to it. Cosign is this labyrinth. How do I simplify this and represent this on one slide? So again, we're looking at the verify blob commands. Fortunately, a lot of the Cosign verification commands, importantly that aren't using OCI, all use this common code path. Where they call into package Cosign verify, and in particular, verify internal. So it doesn't matter if you're verifying a file on disk, if you have an attestation, it all sort of funnels through this verify internal function. And then we know that verification is very complicated. There's all these different steps. So here we're just focusing on verifying the Fulcio certificate chain with the validate and unpack cert with intermediates, which then calls trusted cert that actually performs the verification steps. So for better or for worse, the first thing that we did is we just slammed a bunch of if statements at the top of these commands. This was good and bad. It was good because it was a very expedient way of supporting these new use cases. So today, as of the most recent release of Cosign, if you're using a protobuf bundle, if you're using a trusted root, it will hit this if statement. And then instead of using Cosign's existing verification path, it just calls into Sigstore Go and uses its top-level verification function. We have a high degree of confidence in the correctness of Sigstore Go. I don't want to say it's perfect. There's probably bugs in there. There's probably issues that we'll uncover as more people use it. But we've had external audits. It's hooked up to conformance testing, unlike Cosign. And there's many people who have used it in different deployments. And so it's a little strange to have these two parallel verification paths happening in parallel, but it allows us to help people kind of jump to the future that we want to see. And that allowed us to write this nice blog post where we described how to use Cosign with NPM attestations, Homebrew attestations, and I think this might have been before the PyPI public beta. So I think GitHub artifact attestations was the third interoperability compatibility example that we checked out. If you haven't seen the Sigstore blog, absolutely give it a look. There's some good content on there. But of course, the downside with this is that we're not actually building any sort of interoperability. We're just saying, hey, if you jump to using the new file formats, it'll work. But then how do we get that sort of hybrid support? That is the work that Colleen has been doing. And so she's working on updating Cosign to support what we call the tough v2 clients. And part of that is moving it from fetching all these individual files to fetching the trusted-root.json file. But again, a few slides ago, we had this problem where now that we're using trusted roots, there's multiple time ranges, or for a given time range, there's multiple verification material that could be valid. Cosign doesn't support that at all, and so we were forced with this hard trade-off. Do we re-implement things that are in Sigstore Go in Cosign? I think Colleen came up with a really clever way to approach this, which is to use the specific verification functions in Sigstore Go. So we're not calling the top-level verify function, but we're calling into the Sigstore Go library to perform like just the Fulcio leaf certificate verification if we have a trusted root. And this is a nice trade-off in that we don't have to re-implement a bunch of code in Cosign and then figure out how to test its correctness. And it allows people to start using trusted roots with their old signed material. And so we're providing these stepping stones to help people move into this future. And then the last thing I wanted to talk about was migration tools. It turns out it's pretty easy to take the disparate signed material or a old Cosign bundle and transform it into a protobuf bundle. The only thing that you need to do is that if there was a recore entry associated with that content, you have to query recore live to construct the bundle once. But then once you've done that, you don't have to query it again, and you have the protobuf bundle, which works offline. So we created this helper function that does exactly that. And then similar but different, we also have a helper function for assembling a trusted root file. So you can have your Fulcio certificate chain, your timestamp authority certificate chain, public keys for certificate transparency. It'll output a JSON file for you to use. Dimitri at Yahoo has had a chance to use this for their private deployment, gave us some great usability feedback, and it seems like it's working. So it's always nice to receive feedback from users that things are turning out like we expected. And so here's where we're at today. I didn't, in this talk, cover signing very much. Signing is pretty easy. At the end of a Cosign sign function, you already have all the sign material. So you can just put it in a protobuf bundle instead of putting it in a Cosign bundle. We just added a flag so that you can control what the output looks like. So both signing and verification, as long as you're not using OCI, is in the most recent release of Cosign, version 2.4.0, so you can use that today. There's a number of draft PRs out. Cody was very kind last week in helping me get up to speed on what's going on with OCI. Unfortunately, I didn't have time to incorporate it in this presentation, but check out pull requests 3.888 and 3.889. That's for signing and verifying on the OCI side of things. I mentioned earlier, Colleen is working on the Tough v2 upgrade. That's happening in pull request 3844. And then we've landed these helper functions, but we haven't yet released them. So feel free to check them out. They're on main. They will be a part of the next release of Cosign. Before I get off the stage, I got to have my call to action here. So if you are a Sigstore user and you're not using OCI and you are using Cosign, make the shift. We're ready for you. We have support for protocol buffer bundles. We have support for verifying them with trusted roots. We also have the helpers to help you convert your old material. Let us know what your experiences are, if there's gaps that you observe or other support that you need. And then in particular, if you're running a private instance and you haven't already started using a trusted root, think about moving to it. We have the helper function. We know it's worked for at least one large organization. It will probably work for your organization as well. And then I don't have a good sense of, for the private deployments of Sigstore, how many of them are using Tough or how many of them are not using Tough. I would really encourage you to do so. I know it's an extra step. But again, when you're rotating key material, you're sort of faced with this dilemma where you could make a trusted root into your client that you distribute to people to do verification. But then when you rotate your key material, they have to do a software update to get that new key material. And so Tough is a really great way to support early key revocations or seamless key rotation, which is probably a capability that you are going to want eventually for your private deployment. Thanks.
Have you thought about having the upstream Sigstore Tough root add support for multiple recore instances so that, like, if folks want to run their own recore and sign with their, their own keys and things, but it would be easier for people upstream to opt into trusting those signatures as well?
Yeah, I should have done a longer intro slide. I'm a co-maintainer of Sigstore Go, and I've been tricked into contributing to Cosign. There is not a lot that I know about private deployments and sort of these like hybrid use cases. I would say I'm learning about them. I think that would be a great topic for the Sigstore community meeting. There's also the client's SIG, where we sort of talk about client interoperability. But I think that might be a good question for the community meeting as to like how we want to manage the Sigstore public good instance Tough root. Great.
And I'll also mention, if you have any questions like this, feel free to reach out on Slack. Feel free to file an issue as well. The community meeting, I think, is a great venue as well to have these discussions. Any other questions? All right. Thank you so much, Zach.